Hey, it's Abraham Mirza. Just finished setting up the months for my cosmic calendar. You can see it's about 100 meters. It goes all the way back up to the road. And I just wanted to take this time while I'm walking this out to give a brief introduction. The purpose behind this cosmic calendar, as it spans 100 meters, is to give us an idea of just the scale of the amount of time of different events occurring in Earth's history. It can be kind of hard to imagine 4.6 billion years, but when we put it on this time scale and we see different events like the age of dinosaurs and how long they really ruled for in relation to this 100 meters and this 365 days, 12 months, it can kind of put events like that into perspective. So, real briefly, I set this up over this whole field right here. It's a 100 meter distance between January 1st and December 31st. I was able to use Excel to input formulas, which were able to give me those exact distances. And then I put these stakes in the ground, just general garden variety stakes from Walmart, that I was then able to, to tape on these labels that give us our month markers. And so that's what I use for our monthly markers. And I'm using the same ones for the billion markers as well. And for our events, I have these general garden sign stakes that we've taped the events to. And so now I'm going to be walking the distance and inputting those right after I finish up this introduction with you guys. So I just want to briefly show you each of our events are a certain color, and the color correlates to the events on this timetable. So I'm not sure if you can see it super clearly in the video, but for instance, all of our life events are in pink on this, and so are our life events on our stakes that we're using for our signs. And this has every distance correlated here with the event and the time. In the on the camera it's the left hand side, but it's the right hand side of the paper if you're looking at the paper. So that's how we're measuring it out. And now that I've got this basis down for our months, I'm going to go in and input our billion year markers, and then I'll be putting in the events after that. And here is a graphic display of our events on a timetable. As you can see, millions of years ago at the bottom, and the events on the left, and it shows just when they fall into place on that time scale. So we've got our graph, we've got our events listed here, and I've got a brief little script here to reference that I'll be using as I walk through. So in the next part of this video, I'll be showing you guys the different events, and we'll be walking through, so stay tuned for that. Hey, we're back. So just wanted to show you the final setup. Got the whole thing down, all the way down that way. So just wanted to cover a couple things that I didn't in the last video, but each event has a color coordinated with the type of event. So our white events are our geological events. Our green events are the special events that I chose and selected to cover based off of a personal interest, and we'll dive into each of those individually. Our pink events are our life-based events. Anytime we have some sort of new breakthrough in life, they're going to be in pink. Our yellow events are extinction level events. And let's see, our blue events mark the Earth at billion year ages, and that should about cover it. So without further ado, we'll dive in. All right, we're back, and let's dive right into our cosmic calendar. So here we are at January 1st, all right, approximately 100 meters from our present day, or 4.6 billion years at the formation of our Earth. All right, so let's take a trip a few 100 million years, about 200 million years later, and that'll put us at January 17th, and that'll be the formation of the moon 4,400 million years ago. All right, That's about 4 meters on our cosmic calendar. All right, now if we just keep moving a little further, up next we've got the solidifying of our crust happening on January 25th. All right, that's 4,300 million years ago. All right, and just like that, one more event left, and that's impacts delivering simple organics on January 29th. And here we are already in February. All right, we've already covered about 400 million years on our cosmic calendar in the first month of this. Up next, we've got the rains filling our ocean. Now, there are about 5 events in this cosmic calendar that I'd like to draw your attention to, and this is the first of these 5. It's just a step forward about 10 million years from February 1st to February 2nd, all right? But it's a huge event in our timeline. So imagine the impact that a single storm brings, all right? It can have lasting effects for days on our water levels, and we've seen a lot of devastation from hurricanes and floods in the past, tropical storms, that only lasts for a short duration. Well, in this time period, the rains rained down on our Earth for about 4 million years. So just imagine the effects that a single 2-day storm can have and multiply that by 200 million, and those are the effects that we see of the rains that filled our oceans. So here we are, February 2nd, 4,200 million years ago, and that's how our rains filled our ocean. That's how our ocean is developed. So we're going to keep trucking along here in our cosmic calendar. All right. Our next event we have 13 days later takes us 170 million years into the future, and it's our oldest formation of rocks. So that's 430 million years ago, or sorry, 4,030 million years ago on our cosmic calendar. Puts us at February 15th. All right. So let's keep moving along here. Here we are at the end of the heavy bombardment. February 22nd, 3,950 million years ago, or 3.9 billion years ago. All right. And I'd say of all our events that occurred between January and throughout February, our first 2 months of the cosmic calendar, I would say that this is one of the, if not the most significant event besides the formation of Earth. All right. Because the heavy bombardment ending signified the final size and shape of our planet, right? And if we've learned anything, it's that our mass and radius can have huge effects on the ability of life to take a hold on a planet. So I'd say that the end of the heavy bombardment, the final shape and size of our planet that came with the end of these tons of impacts on Earth, resulted in our mass and radius, which makes it possible for our life. All right, so this is our first 2 months covered, January and February, and this is our progress so far, and that's how much we have left to go. So, that really just puts into perspective our first 800 million years, roughly, and we still have all that way to go. So stay tuned. All right, so here we are at March 1st, all right? And just one step forward, March 2nd, earliest evidence of life through chemical markers at 3.8 billion years ago, all right? Now, if we keep going forward, pretty soon we hit a major milestone in Earth's timeline, all right? Right up here, March 21st, so here we are about 2/3 through the month of March, and we're at Earth's billion-year birthday, the spring equinox. That's all we've covered so far. Still got quite a ways to go, so let's keep going. All right, here at the end of March, we've got a couple major events, all right? First, we've got our oldest fossils, stromatolites, all right? Now, I want to draw your attention to this too, okay? First, it's the oldest fossil, right, on Earth, so that's a pretty big deal. And this is the second of the 5 events that I mentioned earlier that I wanted to draw your attention to, all right? So stromatolites are essentially microorganisms that have left a film behind, which has been cemented by calcium carbonate, which, then leaves those band-like structures that we see on those rocks. So it's our oldest fossil, and it's really just almost like a stain left behind. So imagine, like, you know, you're in a house and you've owned it and lived there forever, and you spill things on the carpet. Maybe you had a big party one night and, you know, you spilled some wine on the carpet, and you sell the house, and a new owner buys the house, and you didn't change the carpet. So the new owner sees the stain, and it's evidence of a past memory or past event that you guys had of that party when you spilt the wine. So it's kind of just the same way. Stromatolites are essentially a stain of that biofilm left behind from those microorganisms, and which was cemented into the rocks all those billions of years ago. So that's 3.5 billion years ago we had that. Now, at about the same time, we've got evidence of our oldest impact crater on Earth in the Pilbara region of Australia. Okay, that also occurred 3.5 billion years ago. Now, throughout this calendar, I told you I was going to be having 5 events of my own that were of interest to me that I chose. This is the first of those 5 events. All right, so bring your attention back to it. And scientists basically recently found evidence that this impact crater, exists in the Pilbara Craton, which for a long time was believed to be formed as a result of, like a volcanic plateau. But recently it's been argued that it could have been formed as a result of a large impact. And this evidence was recently found. I thought this was significant because the next oldest impact crater found in this region was 2.5 billion years ago. So this is a pretty big scientific breakthrough. It shows evidence that, we've got impact craters up to 1 billion years prior to what we had previously thought. So I thought that was pretty neat, and I wanted to include it in the calendar. And here we are right next at April 1st. Now, I'd like to point out that at about this time when Earth was showing its first evidence of fossilized life, Mars is losing its oceans and surface water. So it is entirely possible that just as life was beginning to take hold on our planet, it was dying away on Mars. If Mars followed Earth's timeline, it may have had cyanobacteria like what left behind our first fossils in the stromatolites all those years ago. So something to put into perspective. At about this time, Mars could have had life. So let's continue trucking along. All right. Don't really have any events in April, so quickly going to approach May 1st. All right, that puts us right here on our cosmic calendar. We've come all that way. We've still got that whole way to go. All right, so let's check out our first event in May. Our first event in May is going to be the oldest record of Earth's magnetic field, 3 billion years ago on May 8th. Alrighty. Next up, June 1st. May was a quiet month. Here we are. First eukaryotes, all right, single-celled organisms at 2.7 billion years ago, occurring on June 1st. We're already into our 6th month of this cosmic calendar, and quickly approaching at June 9th, Earth is having a birthday at 2 billion years old. So all this has occurred in the first 2 billion years of Earth. We're not even close to anything related to man, humans being, a part of this Earth at all yet. And we're 2 billion years into this Earth. Next up, our atmospheric oxygen levels grow between 1 and 2%. That's 2.5 billion years ago on June 17th. All right, we're going to continue trucking along. Oldest evidence of snowball Earth at 2.4 billion years ago. That's June 25th. Wanted to take a step back and show you, this is all we've covered so far. Distance-wise, we're about halfway through our cosmic calendar, but there's quite a bit of events going on down there, so we still got quite a bit to cover. And as you can see, we're not anywhere near human beings being anywhere on this Earth yet. All right, here we are at July 1st, and continuing forward until we've got maybe the most significant event on this entire calendar, my birthday, July 7th, which occurred 2.25 billion years ago. So for this was another event that I chose to dive into, and in this event, we're going to talk about what Earth probably looked like at about 2.25 billion years ago. So I've chosen the picture of that algae there because Earth was undergoing, likely during this time period, what's known as the Great Oxidation Event, which is basically when, exactly what it sounds like, Earth's oxygen levels rose by a significant amount, which is a huge step forward for aerobic life on our planet, to then develop further and evolve. But essentially we had these algae and these cyanobacteria undergoing photosynthesis as normal and producing mass amount of oxygen because of this, and in turn that oxygenated our atmosphere. So pretty cool, and it's my birthday, so pretty big event. All right, we're going to keep moving forward. Not a lot goes on these next couple months of our cosmic calendar, but just to kind of put that in perspective, at 2.25 billion years ago is when we started having mass amounts of oxygen coming in, about halfway through the history of the Earth. And it's not even a planet habitable for things on land, much less human beings. So we couldn't have even possibly lived here. Here we are, August 1st. And throughout this whole time period, there's just no way we would have even survived on this planet. So that should kind of put some things into perspective for you. Here we are, August 27th. Earth is 3 billion years old. So again, 3 billion years old. That's pretty far that we've come. September 1st now. All right, we're gonna keep trucking along, and we're fastly approaching October. And we haven't had much going on because Earth is in this period of a lot of climate change and geological transformation. So we're not seeing too many events as Earth is kind of stabilizing out. But here we are, October 1st. All right, another milestone on our calendar. And we're going to take a break here and step away and just look at how far we've come. So we're in our 8th month, okay? 8/12 of the way through our cosmic calendar. That's quite far, and we haven't even seen complex life on this planet yet. So we're gonna keep going, but I just wanted you to think about that. How far we are. We're already in October. All this way through the year in our 8th month, and we haven't even seen complex life yet. So. Oh, will you look at that? Finally, as we were just talking about it, on October 22nd, 900 million years ago, 3.7 billion years into our planet, we've got the first multicellular life emerging. It's pretty crazy. And here we are, November 1st, all right? And this is where things start to get pretty busy on our calendar, all right? So, our most recent snowball Earth, 650 million years ago, on November 10th. And just shortly after, on November 14th, Earth is 4 billion years old. Still not a whiff of humans in sight. All right, 4 billion years old. And we hit at that about the same time, roughly 600 million years ago. Okay, another event that I've chosen because I found it interesting is the formation of the ozone layer. And I wanted to dive a little bit into this. I think it's a pretty significant event for life on our planet. Particularly life to move out of water and onto land on our planet. Essentially, life was kind of limited to water for a while, to the shallow waters, because of the solar radiation that would, cause damage and harm to life on land. And the water provided this natural barrier. Well, eventually, when we had enough oxygen that occurred in our atmosphere, it bonded and turned into O3, ozone. All right, and this provided essentially a layer of protection in our atmosphere that blocks out a lot of the UV rays, a lot of the solar radiation coming from the sun, and allows for life to have less harm done to it and essentially thrive and survive for a lot longer. So I thought that was pretty significant, and I thought that it definitely needed to be included on our cosmic calendar. Let's keep moving forward here. And we've got the Cambrian explosion of life, okay? 542 million years ago. Now, this is when life, obviously really started taking off here. So we'll see, a lot more of that from here on out. We've got a busy calendar, so things aren't going to be quite as spaced out as they were in the past on this calendar, but we're going to keep moving forward. So that's November 19th. All right. Here we are at the first fish. That's 480 million years ago, November 24th. Now, somewhere in between here and the Cambrian explosion of life is about 500 million years. And I want to point out, Venus is theorized to have lost its oceans somewhere between 1 billion and 500 million years ago. So for the sake of this cosmic calendar, I'm just going to make it easy and let's just say that it's 500 million years ago. So now we can get a look and theorize what life on Venus might have looked like. So if life on Venus followed a similar pattern to Earth, and let's say that at about 500 million years ago, Venus was also undergoing its Cambrian explosion of life, we might have seen some complex forms of life on Earth. Assuming that this all happened and took place, we might have seen organisms like the trilobite pictured here, or even, earthworms that, were typical forms of life that took place during the Cambrian explosion of life. So assuming Venus made it that far, it could have had those types of organisms on its planet, which is pretty crazy compared to what it is now. All right, so continuing forward, we've already passed our first fish, and we've got our first mass extinction on this calendar, and Ordovician mass extinction taking place on November 27th, just 3 days after our first fish, and only 8 days after our explosion of life. And I've chosen to go more in depth about this event. This is another one of those 5 events that I'm diving into from our calendar. So I find it particularly interesting because of its kind of paradoxical nature. One of the leading theories of the cause of this mass extinction was actually from life itself. So mass amounts of algae formed during the Ordovician period. And during this, as a result, when mass life comes, mass death also happens naturally in the process of life. So all the algae that formed died naturally, and this decomposition process required tons of oxygen, resulting in a state of anoxia in the oceans. Essentially, there was a lack of oxygen in the ocean because of this decomposition process, which led to death of majority, about 85% of the species that were alive in the oceans at the time. So I thought it was a pretty crazy paradoxical event. Imagine that this is kind of a dark analogy, but imagine you're in a room that's slowly losing oxygen faster than it can, refill it with oxygen. Eventually, you're going to be so low on oxygen that you're going to be in a state of anoxia, and this could result in injury and even fatality, unfortunately. So this is just a simple analogy to use here. Unfortunately, that's what happened in our oceans at that time, and 85% of the living species died as a result of that. And then just 2 days after that mass extinction on our cosmic calendar, at about 20 million years later, we've got our first arthropods on land, November 29th. All right, and then a day later, another 20 million years or so after that, we're at our atmospheric oxygen, which is nearing our present levels. So we're finally at a more habitable version of Earth, and look at that, we're at December 1st. All right, so I just want to take a step back. We're all the way at December 1st. We've finished our first 11 months of this cosmic calendar. We've come quite a long ways to where we are now at December 1st. All right, but as you can see, we've still got quite a lot of events going on. A lot of things happen in this last month, this last 30 days, or 31 days rather. So let's check it out. All right, so we're gonna keep rolling with the calendar. At December 1st, all right, we're gonna move on in. At December 2nd, a couple days in, 375 million years ago, we finally have vertebrates on land. All right, and around the same time, just a little bit after, we've got the late Devonian mass extinction, knocking out 75% of the species. And then just a day later, all right, about 15 million years later, we've got our first seed plants. So as you can see, there's like a constant back and forth battle between extinction events and life, making massive strides, and so it's just kind of a constant back and forth between life and death, the struggle to survive on our planet. So next up, at about 280 million years ago, on December 10th, we got the supercontinent Pangaea forming. All right, now this is another event that I chose to focus more on, so we're going to go a little more in depth, because it's pretty interesting to think that Earth may have looked completely different than it does now, even with all the same continents. All right, and this primarily is due to plate tectonics that are constantly causing our continents to move. Even right now, we're moving at about 2 centimeters per year, I think. So while it'll take tens of millions of years for our continents to really be in a significantly different position, scientists are able to determine a general idea of where they'll be from now, and it could be another supercontinent forms in 50 million years from now. So I thought that was pretty neat, and I definitely thought that should be gone into a little more. So there it is. And you can think of this kind of like our own lives, where you might not see the change that you have over a day-to-day process because of the slow but constant changes that we undergo in our lives. But if you look back after 5-10 years time and see how far you've come, it's quite significant. So the same kind of concept of change over a long period of time of just a continually changing thing like our continents are. So we're going to continue on, and up next at 250 million years ago, December 12th, we've got the end Permian mass extinction. All right, so let's keep going. And after this mass extinction, just 3 days later, we've got our first dinosaurs and mammals. And I say 3 days, but it's been about 30 million years on our true time scale, 3 days on our cosmic calendar. All right, and then we've got supercontinent Pangaea breaking up, almost like it just formed over there just some 6 days ago on our calendar, but really it's been about 80 million years in true time scale. And around this time, we've got the end Triassic mass extinction, wiping out 80% of species at the time. All right, so let's continue on our calendar. All right, and up next, December 22nd, roughly 130 million years ago, we've got our earliest flowering plants. All right, and continuing forward, the next event is a pretty special event to me, and it's one that I chose to include in this calendar. It's the life of Giganotosaurus. All right, roughly 99 million years ago, this giant creature lived on December 24th on our cosmic calendar. Okay, now this was my favorite dinosaur as a child. Lesser known than the T-Rex, but it was actually quite a bit bigger than the T-Rex, enough for it to be, recorded as being significantly bigger than the T-Rex, and there's evidence to show that it may have even hunted in packs. So imagine a group of dinosaurs larger than the T-Rex, a pack of them hunting down their prey. It's a pretty terrifying thing to imagine, but pretty neat, pretty cool. You don't really normally see that, and T-Rex was a sole hunter, a solitary hunter rather. It did not hunt in packs, and Giganotosaurus may have. There's evidence to say that it may have, and actually it preceded T-Rex by about 30 million years, or about 2 to 3 days on our calendar, but 30 million years of time in between Giganotosaurus and T-Rex. So I thought that was pretty cool, and just wanted to include it. My favorite dinosaur. So we're going to keep going, and up next, sad to say, in Cretaceous mass extinction. So right after our friend over there, just 2 days later, but about 33 million years later, we've got that mass extinction that wiped out 75% of the species. Now, I do want to actually go in depth on this event as well, because this is what caused dinosaurs to go extinct, which is a pretty massive thing to have seen, because dinosaurs ruled the earth for about 140 million years. There's our first dinosaurs way back there, some 140 million years prior to this. Just 11 days on our time scale here that dinosaurs ruled the earth for. But I thought that was pretty significant, and the leading theory behind what caused the extinction is a massive asteroid striking the earth and causing, as you can imagine, huge tsunamis and large amounts of flaming debris which coated the earth and caused wildfires and effectively ended 75% of life on the planet, to include all the dinosaurs. Now, if you've ever thrown a rock into a body of water, you may have noticed, the ripple effects, the splashing effects that happen from it. From just like a small little rock, you can see the splash that happens, if you just lob it out there. Well, I want you to imagine something the size of Mount Everest and moving at about 45,000 miles per hour. All right, that was the size of this asteroid and the speed at which it was going. And as you can imagine, the massive tsunamis that were created by something like this, and the amount of debris that went flying, up into the atmosphere and then came crashing back down on our planet, was enough to destroy quite a bit of life on Earth, including the dinosaurs. So that's what happened, and I thought that was definitely something worth going more into, because it caused, we see these dinosaurs as these massive, terrifying but amazing creatures that and what it took to get them to go extinct was, I thought, pretty significant. So I wanted to dive into that. Up next, just 6 million years later, we see early primates on December 27th. All right, just about a day later, but not even quite a day, really more like 12 hours after our mass extinction on the timetable. All right, and here's where things start to get a little crowded. So I might not be able to get in view of these camera shots, but I'm going to put my camera in here. All right, next up, 6 million years ago, on our last day of the calendar year at around noon, we have the formation of the Grand Canyon, right? So, a lot of people have marveled at the Grand Canyon. Some people have gotten to go there. If you're in Arizona, it's pretty close, so you've probably gotten to check it out. I fortunately have been able to check it out, which was a pretty awesome experience. So, and that was just 6 million years ago, occurring on the last day of our calendar event. And we typically look at the Grand Canyon as being this huge thing that took so long to form. And it did, but in the grand scheme of things, it's within our last 12 hours of our cosmic calendar timescale here. So really a pretty insignificant event. So we're going to keep trucking along here. All right, up next, we've got the first hominids 5.2 million years ago, not even at true Homo sapiens yet. And we're already at 2:05 p.m. on our last calendar day. All right, our next event is an event that I chose for myself to add into this calendar, and it's the formation of the Na Pali Coast, and that's on the island of Kauai in Hawaii. Now, that formed about 5 million years ago, and it was a result of multiple volcanic eruptions, which, once the magma cooled, it caused these much more defined and sharp ridge lines than the rest of Hawaii has. And it's really a spectacular, if you get a chance, to Google it up or check it out on images, it's a really spectacular coastline, amazing views. And I was fortunate enough to get to go and do it with my cousin. And there's a picture of me and my cousin and our two friends on the side over there. And we were fortunate enough to get to hike that entire coast. And the Na Pali Coast Kalalau Trail is known as one of the tougher and more dangerous hikes in the world, and so it was truly a really amazing, awesome experience. It was a very challenging experience, but I love nature and outdoors, and so I wanted to include this on this calendar because it really is a marvel of nature and the earth. And so I definitely thought it would be cool to include and just kind of go into the history of that. So there's that at about 5 million years ago. All right, here we are, finally at modern day Homo sapiens. 150,000 years ago, December 31st at 11:42 p.m. and 52 seconds. That's not very long ago. All right, on our last day, about 17 minutes and 8 seconds, I believe. Yep, 17 minutes and 8 seconds ago. That's not very far at all into the past, and here we are. And so, whether that's on a time scale of 1 year, 17 minutes ago, roughly. I don't know if you normally, track time in your day, something took a couple minutes out of your day, and, maybe you spent, 17 minutes between, doing chores, right, like washing the dishes, something like that. We typically measure 17 minutes on a day time scale, this took me 17 minutes to do today. We don't really think of anything that took us 17 minutes in our year, It's not really significant enough of a time to really reflect on in our year and say, oh, remember doing that for 17 minutes this year? We don't really think of time that way. So I want you to kind of take that into consideration, 17 minutes ago on our cosmic calendar is when we've just seen our first, you know, Homo sapiens. And then roughly 9 minutes later, we almost go extinct. So we barely last about 9 minutes on this planet before we have almost an extinction event. Several hundred, you know, pairs of both sexes were able to survive, and so that was able to save the human race. But pretty significant that we barely lasted about 9 minutes on this Earth, and you know, we almost had an extinction event. Now, our last event, ancient astronomers, about 2,000 years ago, which in the grand scheme of things on our calendar was about 14 seconds ago. All right, and we typically think about, you know, things in the last 2,000 years as being majority of our time on this planet as humans. You know, that's what we really think of, and it's only been 14 seconds in the scale of a year. Now, I forgot my my card for this and my stand for this, and I'm about 30 minutes from where it would be, so I went ahead and filmed this without it, and I had an extra piece of paper and a pen, so hopefully I don't get docked too many points. But here's our ancient astronomers 2,000 years ago, and it's a very crude image of a geocentric model from Ptolemy, roughly 2,000 years ago. So, you know, I just wanted you to think about that. In the grand scheme of things, we've come all this way. We've come 12 months, roughly 11 months, really, 31 or 30 days rather, 23 hours, 59 minutes, and 46 seconds. And this is where, you know, we are at ancient astronomers 2,000 years ago, and we're right here, just barely before that is where we are now. So it's pretty significant to think about how insignificant we are in the grand scheme of time. So, you know, dinosaurs ruled this earth for, you know, roughly 140 million years, and, you know, on this cosmic calendar, that's put out at about, let's see here, let's just refresh on the dates here. That's put out at about 11 days, and so dinosaurs for this cosmic calendar length ruled Earth for about 11 days, and on our scale, that same time scale, humans have only really ruled this Earth for 18 minutes, and we managed to almost go extinct about halfway through that. So that's pretty crazy to think about, and I hope that this has helped put that into perspective for you. The fact that dinosaurs have really only been gone for about 5 days, you know, before humans came into existence in the scale of this calendar is also pretty crazy. So we can, you know, take a walk back through our cosmic calendar, and let's just assume that we found ourselves in a position of, you know, a scientist having, you know, discovered another alien Earth, let's say, in, you know, roughly the same distance that Earth is from its sun, you know, distance from a sun-like star, and scientists are able to determine that the planet is roughly 1 billion years old, and they want to know, okay, we're you know, let's say where Earth was at about 1 billion years ago, and let's kind of try to determine what life might be like on that planet at 1 billion years old. So we can walk back through our cosmic calendar, and here we are at about 2 billion years old. So we're going to keep walking until we get to our billion-year marker, and we can use that to determine, you know, roughly what life might have been like on our planet at that time. So here we are at March 21st. Earth's 1 billion years old, okay, and the next closest event we have is our earliest evidence of life from chemical markers, okay, due to a cyanobacteria. So we can assume that life on that planet might have that type of, you know, signature behind it, like a cyanobacteria. So now let's assume that those scientists made a mistake, and upon the correction of that mistake, they've realized that planet that's, you know, in close proximity to that sun-like star is actually 3 billion years old and not 1 billion years old. So let's travel back in time again, and let's get to our 3 billion year marker. Here we are at 2 billion years again, all right? And let's get to where our planet's 3 billion years old, and let's take a look at what life might be like on that planet. So here we are coming up on 3 billion years old. All right, that's August 27th. Now around this time, Earth is going through a lot of different changes, and our most recent event over here is the Great Oxidation, which is occurring. So we can assume that life hasn't quite made it to multicellular forms yet, but that we are approaching it, and you know that the climate and the geography of the planet is changing enough to make that a possibility in the near future. I say near future, but realistically, 3 billion years, and it's probably going to be, that's August 27th, and it's going to be until October 22nd before we see our first forms of multicellular life, and that's 900 million years ago. So in the grand scheme of things, it is still quite a bit far off, even at that 3 billion years from complex life. So hopefully that puts that into perspective for you. And I'm going to wrap this video up because I didn't realize it, but apparently today is mowing day for this field, and they're trying to mow. So I need to wrap this up quickly and take down this entire calendar as fast as possible for them. But hopefully this video has helped put everything in perspective for you, and really just how little our time on Earth has been in the grand scheme of things. So thanks for checking it out, and hope it helped.